Hello everybody, Mr. Gordon here. What I'd like to do is to go through a problem where you have two boxes that are being pulled and they are also connected by a string. This is a pulling type problem, which is actually similar to a pushing type problem, and this might be on the upcoming test, this kind of problem, so I'd like to prepare you for it. The problem that we're going to go through is on page 119, so if you'd like to follow along you can turn to that page. And we're going to look at two questions. The first question is question number 5, and the next question is question number 6, which is the exact same question, only in number 6 we're considering friction. In number 5 we're saying that friction is 0. So friction is 0. The surface is frictionless. So let's begin. The question reads as follows. A 5 kilogram block Y is attached to a 10 kilogram block X on a smooth level table by a light taut string. Calculate the action and reaction forces on the block if a force of 36 newtons south acts on the block. So the question is asking us to get the action and reaction forces on the block. No, on both blocks. Say, well, this force is pulling the whole system together, but this block here is being pulled by the string, and so there's a force here pulling block Y, and this force comes from block X. It's moving forward, it's pulling the string, which is creating this force. So this force is force X on Y. According to Newton's law, every action has an equal opposite reaction, so this string is taut. So even though X is using the string to pull on box Y must pull back on box X over there. So the force here on this block is the force from Y on X. And the question is asking us to find these two. First thing we have to do is begin by drawing free body diagrams for both blocks. So for block Y, we have a force this way, which is force X on Y. We have gravity, we have normal force, and that's it. There's no other force affecting this box. Force of gravity and force normal, by the way, equal and opposite, so they equalize. So the net force, the sum of all the forces on box Y, is this plus that, but I'm going to omit those two for now, just to not have to write so much, because 0, so I just include this one. This is Fx on Y. Net force on this box is resultant from that force. Newton's second law also says that the net force is equal to the mass of the object times its acceleration. The mass here is the mass of Y, and the acceleration is the acceleration of Y. Now, key thing before we move on, we're going to do this for block number 2, for block number X, get a similar equation. But there's a key thing you have to realize, is that as these two are being pulled by this force, neither one is accelerating faster than the other. They are both accelerating forward in the same rate. It's kind of like if I push on you, basically, then all parts of your body are going to move forward. They're going to accelerate equally. Your legs aren't necessarily going to go faster than your head or something like that. The entire system moves equally. So the acceleration of Y is the same as the acceleration of X. And you could just say that this is the acceleration of the whole system. Just simplify it like that. So really here we don't need that Y. Let me see if I say. Yes, I do. I'm going to erase that Y there. There we go. Now, let's look at the free body diagram for, before we do that, have that the net force for box y is this force, Fx on y, and it's also the y times a, so we can equate them. So Fx on y equal to mass of y, which is 5 kilograms times the acceleration. Now, we have two variables in one equation, so we're stuck. This is why we have to look at the next box here, box x. Free body diagram is like this. Force of gravity, force, and they are equal. There's a force of 36 newtons south, and here there's a force Fy on x. So the net force on x of all forces. I'm not going to consider Fg and Fn again because they will cancel each other. So here we have left 36 newtons south plus Fy on x. Hope that's legible. We also know that by Newton's second law, net force must equal the mass of the object times its acceleration. So the mass of x times its acceleration. Acceleration of x is just the same as the whole system. They're all accelerating at the same. So now we equate the two, F net here and F net there. We get 36 newtons south plus Fy on x is equal to mass of x is times the acceleration. Just going to pause for a moment. And I am back. So we are stuck with basically two equations. We have this equation here with acceleration, this variable Fx on y. We have another equation Fy on x and a. We have two equations and three variables. But in reality, we only have two variables because these two we know are related. Fx on y is its third law, it's equal and opposite to Fy on x. Now we can substitute one of them into the equation. So let's see which one we choose. It shouldn't really matter. So I'm going to go with this one here. I'm going to say Fx on y is negative Fy on x. And I'm going to continue this here. Fx on y is just negative Fy on x, and it's equal to 5 kilograms times a. Now I just want to get rid of this negative, so I'll say Fy on x is equal to negative 5 kilograms times a. Now I'm going to take this and sub it into here. And I'll continue up here. So 36 newtons south plus Fy on x is negative 5 kilograms times the acceleration. And this equals to 10 kilograms times the acceleration. 36 newtons south is equal to 10 kilograms times acceleration, and then plus 5 kilograms times the acceleration makes 10 kilograms times the acceleration. Therefore, the acceleration will be 36 newtons south divided by 15 kilograms, which gives us 2.4 meters per second squared south. What this is, just take a step back. This means is that the entire system is accelerating forward at 2.4 meters per second squared south. And this applies both to x and to y and the whole system. Now the question was actually asking you. So to get them, we simply plug the acceleration into the equation that has them. So x on y is 5 kilograms times 2.4 meters per second squared. It should give us, let me use my calculator here, 5 times 2.4 is equal to 12 newtons, and I should have included units, didn't, but this will be south. If you include units, you will see that because you're using south here, it should be there as well. So Fx, this one here, is 12 newtons south. In 2.4 meters squared south into here, into this acceleration, after doing all the math in the algebra, Fy on x is equal to negative 12 newtons south, or 12 newtons north, which you can double check against Newton's third law here, which says that these two must be equal and opposite. So here now we have the answers. We know what this force is and we know what this force is, and that's question number 5. Now we'll move to question number 6, which involves friction.